about what might happen when we add a medicine. So this is an overview of some of the important metabolism phenomenon. And if you look, remember there are two systems we use really to metabolize most of our drugs. First order and second order kinetics, if you remember that, and it's either they go through glucuronidation or they get oxidation reduction reactions. You know, I was a philosophy major, so it's really hard for me to say stuff like that. So anyway, if you look, the first four drugs we have on this go through glucuronidation. Morphine, oxymorphone, tapentadol, and hydromorphone, or the acronym is MOTH. Now, glucuronidation is a much more stable system, much less affected by other things. Other drugs have very little effect on either enhancing or limiting the effect of glucuronidation. So that class of drug, maybe those drugs for people on complex medical regimens for other things, where you're worried about P450 interactions, that might be a group of drugs worth thinking about. The others, oxycodone, hydrocodone, combination products, tramadol, codeine, fentanyl, methadone, oxycodone combination products, go through the P450 system. And you can see that its 3A4 is very important for many of them. 2D6 is there, but what does 2D6 do? It turns on the drug. It turns on the prodrug and makes it into the actual drug. So variability in 2D6 is more going to be a manifestation of lost action or too much action. If there's a famous case that's been written up in the New England Journal about a hypermetabolizer through 2D6. So don't rely on trying to remember this. I don't. I have it in my office. In every exam room, I have this table, so I can refer to it, and then I do drug-to-drug interactions with my patients. There are some other important interactions. Again, Charles will spend more time going through this, Dr. Argoff, I should say.